world, we know that's not the end of the world because then you can move it to the other side and then isolate. And you're like, oh, there it is. I can just, it's this thing, right? The challenge is when you do parts on this one, it was like, oh, okay, u squared is x squared. That means v prime has to be 1 over x squared dx. You do it out, and then you end up with this thing right here. And you're like, oh, you can actually use parts on that. And you know you can use parts multiple times. So you use parts again. There's only one thing you can choose because you have to let u equal tan inverse. Why can't tan inverse be v prime? Why can't, what? Because what? Yeah? You do not know the integral of tan inverse. That's something we do not know. So you have to do this, and you're cranking along, you're like, oh, you generate the same thing over here, which is fine, because then you could move it to the other side, right? But here's the thing, look what you end up with. Look at that bottom line there. This minus itself, and then this on both sides. So what do you end up with? 0 equals 0, yay! So I went back and I looked, and I was like, what's the algebraic mistake, Dad? If you got like one sign wrong, it collapses, right? So then I finally bailed, cried to Uncle and said, okay, fine, I'll just look up what the answer key does. You ready for how you do this one? So this is what you can do, which I saw this once last year. Ty Lee showed this to me, and I hadn't seen it. I can't remember the last time I'd seen it. So look what you can do. You can turn this into this. So what did I do there? Nothing, right? Because what happens when you add and subtract 1? Here's the problem with that step, though. It's super hard to recognize because how many things can you add and subtract? All of them, right? This is one of those magical things where you just pull something out of thin air because it makes it nice. Here's why. Because this is equal to the integral from 0 to 1 of x squared plus 1 over x squared plus 1 dx, right? Minus the integral from 0 to 1 of what? 1 over 1 plus x squared dx. So what does that equal? What does that equal? The integral of, from 0 to 1 of dx, right? Plus, or sorry, minus, and what's the integral? What's the integral of 1 over 1 plus x squared? Inverse tangent of x from 0 to 1, right? So this is just x minus tan inverse x from what to what? 1 to 0. Isn't that thoroughly frustrating? Yeah, it is. So basically, what this, I don't want to say it's impossible for this to happen, but this whole like adding a constant and subtracting a constant, keep that in your mind as something that can be done. You make it so that you can turn the whole thing into 1 and then have this other thing left over that is easier to integrate. So then when you do this out, what do you end up with? What, 1/2 x squared, don't integrate again, sorry. What's tan inverse of 1? Pi over 4, right? So what is this? 1 minus pi over 4 minus 0. What's tangent to 0? Tan inverse of 0 is 0, right? Yeah. 0. So then what do they have here? So this is just 4 minus pi over 4. So is it up there? Yay. When I got done originally, I was like, okay, 0 equals 0. I see a 0. Like, I want that to be true, but like 0 equals 0 is not the same thing as x equals 0. Sometimes you can get close enough and you're like, I have no time, I just have to guess something. But in this case, this is a very specific method. And it's also super frustrating because like this feels valid, right? This feels okay, but it isn't. Doesn't help. So I just want to look at it and you're like, oh sweet, I noticed something. You can't use u substitution, right? Because there's no term on the outside of the radical. So you're like, oh man, so this is going to be the integral from 0 to 1 of the square root of what? X minus 1 squared. So then you're like, ah, sweet, 0 to 1 of x minus 1 dx. So you're like, ah, sweet, so it's like 1/2 x squared minus x from 0 to 1. So you're like, ah, negative 1/2. And you're like, I'm done, and you move on, right? Here's the problem. Warning bells should go off because this is the principal root. Is there any negative sign outside there? Is there any negative sign out there, right? So this is only what? Only positive. This is only positive. This is a nasty, hard question. So when you get a negative, just be super careful. An alarm bell should go off because the answer should be what? It should be positive. Here's why. When you graph this, you have to remember that when you square root a square, you're always going to have a what? Positive. So there's an error somewhere in here. Where's the error? Can someone tell me where the error is in here? There's an error somewhere in here. It's a rule from what to what? 0 to 1. You're doing this. So what's the actual answer for this one? It's 1/2. You have to use the absolute value here. So the answer is this, which is 1/2. You have to be super careful on that. That's a nasty hard one because it looks deceptively simple. And you think you find the trick to it, right? You're like, can't do parts, can't, oh, I just factor it, it goes away. But you need to be able to have that warning bell go off in your head. So what kind of problem is this? What kind of problem is this? Yes? It uses distance, but what type of distance are we trying to find? We're going to write the equation for a distance and find the what? The what? The minimum. And so this is an optimization problem, right? So effectively, we're going to write an equation, take the derivative of it, set it equal to 0. What is by far the most common thing you do in calculus? Take an equation, take the derivative, set it equal to 0, and then draw some conclusions based on that information. So you have this curve right here, and you have this point. So what do you have to write first? What's our first, what do we need to write? We have to construct something. What do we need to construct? This curve right here is doing this, right? Here's this point. Let's just call it here, 0, -1/2. This is not to scale and meant to be any way totally representative. What do we need to write the equation for? Are we minimizing the chocolate pound? No, what?
Distance between a function and a point.
Correct. So if this is a point right there, let's just call it point, what do you want to call that? Let's call it AB, just for clarity's sake. And we have that point there. What is the distance between those 2 points right there? The distance is going to be what? The square root of what? A minus 0 squared plus what? B plus 1/2 squared. Is that correct? So that is the distance between the points in terms of what? A and B. We can use something better than that, actually. Let's just call it X and Y for clarity. I guess that's better. But the distance in terms of X and Y is this. And instead of A and B, what should we write? X and Y. So we know the distance in terms of X and Y is the square root of X squared plus Y plus 1/2 squared, like this. Correct? Do we have a relationship between X and Y? We do. We know that X squared plus 2Y is equal to what? 0. So what does Y equal then? Yeah, so 1/2, -1/2 X squared. So where can I plug that in? For Y. So now we have the distance just in terms of X, and that's going to be X squared plus what? -1/2 X squared plus 1/2 squared. How's my algebra? What do I need to do now? Speak so humans. So could someone walk me through here? D prime of X is going to be equal to what? 1/2 of what? Plus this thing, right? -1/2 X squared plus 1/2, like this. To the what? -1/2 times the derivative of the inside, right? So what's that going to be? 2x minus, oh, sorry, plus, I got to be careful here, plus 2 times -1/2 X squared plus 1/2 to the what power? 1 times what? -2x, like this. Oh, it's just -x because it cancels with the, yeah, -x like this.
You know when you write a minus and you try to...
How's that look? Is that decent right there? We are interested in knowing when this derivative is equal to what? 0. How do you make a fraction equal to 0? What's the only way for a fraction to be equal to 0? The numerator, right. So now we're just going to look at 2x minus 2x -1/2 X squared plus 1/2 equals what? 0? There's a reason I didn't multiply it out. Don't multiply things out unless you have to. What can I factor out now? How about 2x? What is that going to be? 1 minus what? -1/2 squared plus 1/2 equals 0. So what do we have here? 2x and what? 1/2 X squared plus what? Plus what? 3/2?
1/2.
Hmm?
I think it's 1/2.
Oh, it's minus. Thank you. It is minus 1/2. Equals 0. I could factor out 1/2 if I wanted to. So what do I get here? X times X squared plus 1 is equal to 0. So X equals 0 or what?
Something imaginary.
Plus or minus I. So we're in the real number plane, right? So what's our answer so far? What do we think it is? 0. Is that a, and what does an inflection point mean? What is an inflection point? Not sufficient. That happens, but you also need what? The sign of what? The sign of what has to change? It's where the sign of the second derivative changes. That is correct. It's what you said. It's where concavity changes. Concavity changes. So what do we need to actually find on this thing? Second derivative. All right. It's good time. Good times, huh? So if we do the first derivative, if we do the first, now, do you want to multiply this out before or after you do the derivative? Buddy? Yeah. Plus the first, what's the derivative of arctan? Correct. So let's clean this up a little bit. So y prime is equal to tan inverse of x plus 1 over 1 plus x squared. So what's y double prime going to be? 1 over what? 1 plus x squared plus, what do we have to use? Low d high minus high d low all over what? Low squared. Nice. Low d high minus high d low? Low d high. So it's low d high minus high d low over low squared. There's a swing song that one of my teacher friends would sing, like low high d high, low d high. Never really got it. Low d high, just low times the derivative of the high, high times the derivative of the low over low squared.
I always wonder what that means.
That's, you understand now?
Yeah.
There you go, good.
I'll just end up using
What?
the product rule.
Is there another way?
I always just make it like
To do now, we're interested in where this equals what? Oh, this is squared, right? This is where this equals 0. So what do we need to do with those two fractions? So we're going to get 1 plus x squared plus 1 plus x squared minus 2x squared all over what? 1 plus x squared squared equals 0. Again, fraction equals 0. What's the only way for a fraction to equal 0?
wait, where did that x plus 1 go?
Where'd it go? Where'd it go? I needed a common denominator, so what did I multiply that by? 1 plus x squared over 1 plus x squared. So what has to be equal to 0 if we want this fraction to be equal to 0? The numerator. So what do we have here? 2 times 1 plus x squared minus 2x squared is equal to what?
Well, if you just do it out, 2x squared's going to go.
I'm trying to get there, please. I know, I'm trying to get. Again, needed to write the numerator separately. I'm trying to do the whole story with all the sentences. All the sentences, that's right. So you have 2 plus 2x squared minus 2x squared is equal to what? 0. So we have 2 is equal to 0. So either we've done the algebra wrong or what?
No, you did the algebra wrong.
I did? What did I do wrong?
Where's your x plus 1 I meant in your quotient?
Oh, where did I get it wrong?
Because you have an x, but you don't have your x plus 1.
Oh, I see. So this is supposed to be x squared. This is supposed to be x plus 1, right? Like this, times 2x. Ah, thank you. Oh, Mr. Seaman, what's going on today? Man, so close. Okay, so what do we actually have here then? So yeah, we have 2 times 1 plus x squared minus 2x times x plus 1 equals what? 0. Is that better? Is everybody following me now?
Where did that 2 come from?
Where'd the what 2 come from?
That 2 times 1 plus x squared.
You have to multiply this. I just skipped a step again. It's my bad. Okay. So you have 2 plus 2x squared minus 2x squared minus 2x equals 0, right? Is that correct? That goes away. So we have 2 minus 2x is equal to 0, so x is equal to what? Uno! So now x is equal to 1. You plug 1 in. What's arctan of 1? Pi over 4, right? So we want y when x is 1 is equal to 2 times pi over what? 4. So what is it? Pi over 2? So is it e? Woohoo! Together with spot checking by leaning and Eva, we have completed this question. What do I find first? Oh, so what's dy dx going to be? 2x. Nice. Now what? Now what do I do? Put that over du dx? Put what over du dx? What do you mean? So do this over what? Du dx like this? So I have to do that on both sides? Oh, just find out what du dx is? I was like, can I just do that on both sides? Is that okay? Okay, yeah. So we need to find du dx. Like this, you mean? Is that okay? So what's du dx equal to? 2. So we know that dy du is equal to what? Dy dx over what? Du dx. So this is just 2x over 2. So that's equal to x. That's nice. Cool. What could you do theoretically first on this? I would draw a picture, yes. So we have y equals 1 over x. So that's going to be this, right? The line x equals m and the line x equals 2m. Oh, this is cool. So this is x equals m. This is a cool question. X equals 2m. Ooh, I like this. Nice. The area of this region. So when it says the area of this region, it says as the area of this region is independent of m, decreases m. What could you set up right now? An integral. An integral from what to what? M to 2m of what? 1 over x dx. So what's that going to be? The natural log of what? Why do you need the absolute value? It's always going to be above the x-axis.
But isn't there a negative part, like 1 over x?
Oh, you're saying m is greater than 0 right here.
Oh.
You can take care. No, you can take care of that. This would be a much different problem if m was arbitrary. So if we do this now, what's this integral going to be? The natural log of what? Well, just it's the natural log of x from what to what? M to 2m, like that. So what does that mean it's going to be? It's going to be the natural log of 2m minus the natural log of what? Natural log of m. When you subtract logs, what can you do? So this is the natural log of 2m over m. So what's that going to be? Natural log of 2. So what's the answer? Does it increase? No. Does it decrease? No. So which is the answer? Regardless of what m is, it's always going to be 2. It's independent of m. That's really freaking cool.
Well, wouldn't there get to the point where, like,
So what do we have to do for this one?
I just
Cry a little bit.
just where it looks higher.
Well, the problem is you want it, like, first of all, you have a limited number. You have a limited number of ways in which you can do these things, right? Limited number. Does u substitution seem like it's going to work?
No.
It does not, right? Because there's no like x sitting out the outside to cancel out with your u. Parts, you're like, oh, I don't want to have to do parts on this. What I recommend you do, and I have not done this one, so this is me trying to do it the same way you might do it out in your head. Write this out without the negative exponent. What does this look like? It's 0 to 1 of what? What does that look like? It is to the negative 3/2 power. So that's 1 over 4 minus x squared to the what power? 3/2, like that. And it's dx. This substitution right here. Let's try doing this substitution. So if we do this substitution, we end up with the integral from what to what? We have to go from, we have x is equal to this. These are all x values, right?
0.
The sign of what is 0? 0. And then if we go to 1 here, so we have x is equal to 2 sine, so sorry, not x. 1 is equal to the sine of theta like this. So when does sine of theta equal 1/2? You can do it. When does the sine of theta equal 1/2? 30 degrees, which is pi over. Okay, so we have our limits of integration now. We have our limits of integration. Excellent. So then we have, what do we have now? 4 minus what? 4 minus what? Squared, so 4 what? 1 squared theta, right? And then we have, instead of dx, what do we have? We need to write it as what? 2 what? Cosine theta d theta? Because what is this? That is what? Dx. What? To the negative 3/2, correct. Negative 3/2, that is correct. Here's why this is really nice. What is 4 minus 4 sine squared theta? What can you factor out? So you have 4 pi over 6 of... Oh, thank you. Thank you, thank you, thank you. So what is this? 4 times 1 minus sine squared theta to the what power? To the what power? to the what? Oh, negative 3 halves. We can factor out the 2 cosine theta d theta like this. Is that correct? What is 1 minus sine squared? So what do you have here? 0 to pi over 6 of, what is that? The square root to the negative, it's 1 over 8, right? It's 1/8 times cosine squared theta, right? To the negative 3 halves times cosine theta d theta. Is that correct? Am I doing okay there so far?
Where did the 8 come from?
Where did the 8 come from? That's 4 to the negative 3 halves. It's the square root of 4, which is 2. 2 to the negative 3 is. Are we okay so far? What power is cosine here? 1. So what do we end up with here? 2 times the integral from 0 to pi over 6. We can pull this out and make it 2 over 8. Is that okay? So it's going to be... Oh, the problem is... Ew.
But you can just make the cos squared theta. Can you just make it cos theta times the cos theta?
Well, no, it's to the negative 3 halves power, right? It's not the same base.